हेलो, वेलकम टू प्लूटस IAS। आज हम एक इम्पोर्टेंट कॉन्सेप्ट देखेंगे रियल एनालिसिस में, लाइक लिमिट पॉइंट ऑफ ए सीक्वेंस। Also, we have studied about the limit point of a set. There is a difference between the limit point of a sequence and limit point of a set. For a set, we define the limit point. Now, if S is any non-empty subset of R, then any real number L is said to be the limit point of set S if each neighborhood of L contains infinite number of elements of the set S. But in case of limit point of a sequence, suppose we have a sequence, let an be any sequence or Sn. So an, then L is said to be limit point of sequence of the sequence Sn if each neighborhood of L contains infinite number of terms, that is important, terms of the sequence Sn. So each neighborhood of L contains infinite number of terms of the sequence. Or in case of limit point of a set, there is a difference between the limit point of a set. Okay, limit point of a set, we have already done it, so you can watch those videos. Limit point of a set, what is the difference between the limit point of a set? In that definition, we have L is the set to be, everything is same. L is said to be the limit point of set S if each neighborhood of L contains infinite number of element of that set, and there is a difference between the element and terms. So for example, like suppose you have a sequence -1 to the power n. Now that is a sequence, and now what is the terms? S1, S2, S3, S4, S5, S6, and so on. These are the terms of the sequence, and we know that the sequence has infinite number of terms. So now what will be the first term? -1, 1, -1, 1, -1, 1, and so on. There are infinite number of terms in a sequence, but what the range set? Range set of this sequence is only 1, 1 minus 1. Range set of Sn is S equal to only 1 and -1, which is a finite set. And this set, range set S, or we can say that this set S has no limit point. As S is a finite set, and we know that finite set has no limit point. As in case of set, when L is said to be limit point, L is said to be limit point in case of set if each neighborhood of L contains an infinite number of element of the set. And if the set is finite, then obviously the set has only finite element, then each neighborhood of L can never contain infinite number of element of S, and in that case set has no limit point. But in case of now sequence, our definition says that each neighborhood of L contains infinite number of terms of the sequence. And now, like in this case, suppose this is our real line, and 0, 1, and that is -1. What is neighborhood? We know about it. That is our real line L. Then what is any L plus epsilon, and L minus epsilon is the neighborhood of L. We know about the neighborhood. So we have already covered their topics, like what is the neighborhood, what is the limit point, and what is the interior point, and so on. So you can watch those videos. So we know about the neighborhood of L. That means if you take L plus epsilon, at L minus epsilon to L plus epsilon open interval, that will be the neighborhood of L. Very well. So we can take any neighborhood of L, that is the neighborhood. Okay. So L have infinite number of neighborhood. Now each neighborhood of L, that means take epsilon as arbitrary, epsilon greater than 0, so L minus epsilon and L plus epsilon will define every neighborhood of L. So each neighborhood of L contains infinite number of terms. So now in this case, I say that 1 is the limit point. In case of sequence, 1 is the limit point. Why? If take any neighborhood, however small we take, we know that here S2, S4, S6, S8 and up to infinite, all the terms are here. S2, S4, S8, all the terms, the value of all the terms like S2, S4, S6, S8, infinite are 1. That means here 1, that means if you take any neighborhood of 1, obviously in this neighborhood you can take any neighborhood, however small or however big. Obviously each neighborhood of 1 contains infinite number of terms of the sequence. Similarly minus 1, each neighborhood of minus 1, you can take any however big, however small. If you take any neighborhood of minus 1, obviously certainly this neighborhood contains all the neighborhood of minus 1 contains here in this case like S1, S3, all the S5 and all the terms like this S1, S3, S5, S7 and so on. Infinite number of terms are also here. So minus 1, each neighborhood of minus 1 contains infinite number of terms of the sequence. That means minus 1 is the limit point of the sequence test. Also 1 is the limit point of the sequence of the sequence Sn. So 1 and minus 1 are the limit point of this sequence. But what is the range set of the sequence? Range set is the 1 and minus 1. And in case of limit point of a set, this set has no limit point. As we know that limit point of a set, that means each neighborhood of L contains infinite number of elements of S. Now here elements are only 2 elements. So any real number, any neighborhood of any real number can never contain infinite number of element of S. That means no real number is a limit point of this set. So this set has no limit point, but this sequence has the limit point minus 1 and 1. So now see again the limit point of, we have already completed the limit point of a set. Now we are discussing about the limit point of a sequence, but I mentioned also the difference between the, what is the difference between the limit point of a set and limit point of a sequence. So in case of limit point of a sequence, any real number is said to be limit point of a sequence Sn if each neighborhood of L contains infinite number of terms of the sequence. For example, minus 1 to the power 1, minus 1 to the power n is a sequence has two limit points, has two limit points 1 and minus 1. 1 upon n, sequence 1 upon 1 has limit point 0, only one limit point, that is one limit point, that is has limit point 0, only 0 is the limit point. In this case we can see that the each neighborhood of 0 contains infinite number of terms of this sequence. We can imagine, you can see that that is our line 0, that is the 1 by 2, that is S1, S2 and so on. If you make any neighborhood, if you take any neighborhood of 0, obviously after a certain term, all the terms of the sequence 1 upon n will just here belongs to here. That means each neighborhood of L contains infinite number of elements of S. So that is the concept of, that means definition, or you can say that the concept of limit point of a sequence. That is very important concept, and we must have clear the difference between the limit point of a sequence and limit point of a set. In sequence, now we're talking about the terms, but in set we're talking about the elements. So we'll continue it in next class, any other concept. So in the next video we'll see another important concept. Thank you.